비디오는 필요 있나요? 비디오,
아니요, 아니요.
그냥 그 화면
네네.
교육만 하면 되나요?
아, 네네. 녹화만 하는 거.
오케이. 알았습니다. 이게 녹화돼 있는 거죠? 그죠?
네. 네, 지난 타임 저희가 충전을 안 해놔가지고,
이거.
네, 혹시 몰라서 하나 예비용으로.
그래요? 오케이, 오케이. 그, um, morning, everyone.
네.
Um, today,
Um, um, I'm recording
our lecture. So, so I'm gonna use the slides because we're going to share the screen with the
student when for this. Okay.
mm, so um so uh,
So equilibrium. Okay. So we determine the intersection of the demand curve and um, then we learn in the lesson. It is not optimal, not optimal. This is optimal. So there should be less freeway user than on the equilibrium. And then we learned ways to prove why this is socially optimal. Um, one way to prove that this point is socially optimal is to evaluate the random total cost. Okay, so so that is T, and that is um, marginal cost. Okay, and so one thing you want to remember is that the area below the marginal cost curve is corresponds to the total cost of all the freeway users. So when there is that level of freeway traffic, the total cost of all the freeway users is the area, okay, on the marginal cost curve up to this point, and then the rest in the society use the alternate route. So is their total cost is this red area, okay? And then this total cost, which is the sum of the total cost of all the freeway users plus the total cost of all alternate route users, that is grand total cost. That is minimized when it is at the social optimum. Okay, when that traffic volume is determined at the intersection of the marginal cost and the demand curve. Okay. Yeah. But what is the problem? The problem is that equilibrium, this grand total cost is not minimized. Okay. To see why grand total cost is not minimized, we compare it to the equilibrium. So this is average cost curve. Okay. And equilibrium traffic volume is determined at the intersection of AC and the demand curve. So this is equilibrium. Okay. And let me ask you to calculate, define the area that corresponds to grand total cost under the market equilibrium. Okay, grand total cost under the market equilibrium. That is when there is that freeway users, the total cost of all the freeway users is computed by integrating the area under the marginal cost curve. Okay, so at TEQ. Then the rest use the alternate route. So their total cost is this blue area, the red area. Okay. Now we are ready to compare rent total cost at social optimum and that at equilibrium. The difference between the grand total cost is, let me see, this area, this area. So that area is the difference between grand total cost in equilibrium and under the social optimum. So at which situation the grand total cost is higher? In equilibrium, this point is higher. This area, so the grand total cost is higher by this amount. Okay, by this amount. So this is kind of triangle. Okay. So this triangle is important, okay, in economics because it indicates the welfare loss of congestion. Okay, the individual's failure, so the welfare loss that is incurred because of individual's failure to achieve the social optimum. Okay. Okay. So grand total cost of all travelers under the laissez faire. The equilibrium is illustrated by yellow and blue area. And that under the social optimum is illustrated by this area. The difference between the two is the yellow area. Okay. So that is the welfare loss of congestion. Okay. Yeah. Is it really large? Does it look like a large area? Does it sound very large social cost? Okay. Economists, okay, wanted to quantify it, okay, to see whether traffic congestion is really a big problem. So they use data from highways to econometrically estimate the demand function, demand curve, and the cost curve. Then they are able to quantify the triangle area, and then they find that the area is substantial, so that traffic congestion is a substantial social problem. Okay, so that this study is not irrelevant, okay, so it's a relevant topic for us. Later, okay, so maybe next week we will briefly talk about how to use data to, to identify, so we call it by the slope of this cost curve. Okay? Then if we know the slope, then we can actually quantify the yellow area. Okay, so in particular, in the U.S., from major highways, some studies find that the yellow area is $30 billion US. 30 billion. Is it large or small?
maybe small because comparing the size of the U.S. economy, it makes it small. But 30 billion can be regarded as a large. It can be comparable to other social expenditure. Okay. Okay. Yeah. Then yeah. So and then even that you agree that you perceive it as a social, a big, substantial, and significant social problem, we need a policy to remedy this problem, okay? so that we don't waste this welfare. So the question is how to develop such a policy to remove this social welfare. It would be not a problem if we have a social plan, like North Korean leader, like the king in Joseon Dynasty. Okay, so then that person is called social planner. Okay, and then we have to assume that the planner is benevolent, meaning that he cares about the welfare of the society, not about the welfare of himself and his family. Welfare of them. So I care about your total welfare of 100 students who are all different in terms of interest and across. I want to maximize it so that you can trust my my will. And so, for example, for evaluation, it would be not good if I give A plus to all of you. Maybe the goal is to maximize social welfare, which includes not just the grades by themselves, but also your learning outcome. If I give A plus to everyone, your learning outcome would, you have no incentive to study hard. Okay, so we have to careful about that. Okay. Okay. So our goal. Okay. So the planner's goal is to achieve efficiency. So in economics, efficiency means it's total welfare, the maximization of the total welfare or minimization of the total cost. Okay. So that's what we call efficiency. And then the society pursues two goals. One is efficiency, and the other is equity. And maybe by equity we call inclusiveness or equity or justice, whatever we define. But economics tends to focus on efficiency. So that is also the case in this model. So we don't care much about the equity because it's difficult to incorporate equity because but economists can also incorporate the equity concern framework. So for example, so we will discover that if this optimal policy is carried out, some people will not like this policy, and some people will favor this policy. In other words, there are people who benefit from this policy, and then people who lose from this. So we have to make this policy. But in this simple initial situation, we care about the total. Okay, so total cost and the total welfare. So our goal is to achieve the efficiency in the first stage, and then we care about this equity concept, right? Okay. So the planner, okay, so assuming that this planner has goodwill and benevolent, and then the planner's goal is to minimize the current total cost. Okay, so the question is, what would she do? What would be her choice? So when the goal is to minimize the current total cost. Okay. So perhaps Kim Jong-un, the North Korean leader, will pick this point. Okay. Because he knows that this is socially optimal. Okay. They will say, is it really true that
would Kim Jong-un will choose this point? We don't know. Okay, so this is hypothetical. So we have to assume that Kim Jong-un is benevolent, okay, and then he knows everything. So that's important. He knows everything about individuals' preferences, individuals' situations. Okay, he must know who is good at which one, who has lower cost between freeway and alternate route. In other words, he needs to have this full information about the profile of this alternate cost from the highest to the lowest. Then what he would do is to dictate individual choices. Okay, because you have the highest alternate cost, it is good for you to use the freeway. Okay, because for you freeway is cheaper. Okay, for you, okay, alternate cost is cheaper. For you choose alternate route. Okay, because you have the lowest alternate cost. So in other words, from the highest to the lowest alternate cost, knowing that their exact alternate cost information, he will dictate their choices so that those whose alternate costs are higher use the freeway, and those whose alternate costs are lower use alternate route. Okay. So then, and then until this point here, so what the planner would choose is so first sort individuals by their alternate cost. Then from the first one up to this T optimal until this person, what is their choice? They are allocated to women. Okay? Because their alternate costs are higher. Okay? And then from the next person, and up to the last person, okay? Then they are allocated to women. That's what the social planner would dictate. And then we assume that he is able to do so. Okay? Then make okay. But then, okay, in other words, the benevolent social planner will choose an outcome that would be optimal for the society as a whole. Okay, that's what the social planner would choose. Okay. The question is, the problem is that there is no such planner in the on earth. Okay, so even Kim Jong-un or kings in Joseon dynasty, there's no such plan. Why is it so? Even though we believe that they have goodwill, they have no exact information about individuals' preferences. They don't know. They don't know who have higher internet content or they don't know who's good at engineering, who's good at economics, and who's good at making music. Okay, so they don't. So it's inefficient if one person allocates individuals to different activities. Okay, different production activities. Okay, that's why the planning system, okay, like Soviet Union and North Korea faced. Okay, okay. So then we need another policy here, a different approach to this problem. So what is the approach here? So let's read that. So we need, therefore, to develop a policy in decentralized economy. What do you mean by decentralization? Decentralization means that individuals are decentralized. There is no central planner. Okay, so we have to admit that there should be no plan. So we are living in a free economy, democratic. Okay, so okay. So dictatorship is not an option. Okay, so instead we seek to achieve the same goal through policy within a decentralized city. Okay, decentralization means that individuals still choose their own best choice. Okay, this is a free market still. Okay, so each of you have your own goal, and then you should be allowed to choose whichever best for you. Okay. Then to develop such a policy, to achieve the social optimum in a decentralized setting, for the first step is to understand the real problem. So what is the real root problem of this congestion model? The problem is that individuals don't incorporate the external cost into as their private cost. So you care about your only cost, but also not the cost that is borne by others as your private cost. So that's externality. Okay. So private cost is perceived as your own cost. Okay. But private cost does not include the external cost. Okay. But true cost borne by the society is the social cost. Okay. Which includes think about your cost. Okay. So private cost, okay, private cost, this is your own cost, okay, so your own cost, the cost of using the freeway, the private cost, cost of using the freeway, right? Okay. Yeah, so by definition, this is private. Cost of individual freeway, okay? But then we define social cost, so marginal, okay, so marginal social cost, okay, includes not just the private cost, but also the cost that impose on other people. Okay. So this is marginal social cost. Okay. Which includes your private cost and the cost borne by the society. Okay. So yeah, so when you decided to go to Yeouido last weekend, there was a lot of people who wanted to see this I don't know English support code, okay, support code, okay, and then there is a long queue, okay, behind the main support code hill, okay, and then when you decided to go to Yeouido station, the walk from Yeouido station to Yunjungno, okay, you you uh you you decide whether to or not to go to based on your private cost, but there are so many people there. And then by deciding to go to Yunjungno, you basically you are affecting other people's cost negatively because this is so congested and crowded, so that you increase others' cost, but your private cost is only your private cost. Okay. Yeah. So that's why there are too many people. So too many. So more people than that is optimal for the society in the Yeouido area. Okay. Okay. Yeah. So what is the solution then? So we already discussed the solution. So what if people perceive, flow to achieve the social optimum? What if we let people correctly perceive this social cost as their private cost. What if this external cost is internalized, meaning that this externality is considered as your own private cost, part of your cost. So in other words, we want to, so the question is, can this cost, social cost, this, can this social cost be okay, sorry, red one, I'm looking for red one. Um, so can this cost, social cost, can this social, sorry, can the social cost be regarded as private cost, the new private cost, new private cost, new private cost. So how can this social cost be regarded as your new private cost? Okay, so which policy induces you to regard this social cost as your own private cost? Okay, which policy? Okay. Policy? Yeah. Do you have that in your mind? There's a form. Okay. So the idea is that, okay, so the idea is that uh, the idea is that that externality cost, so P G prime, that is something that you pay, okay? Something that you pay in the form of condition. You don't care about this externality cost. Now I develop a policy maker that as a result of this imposition of policy, you regard that externality cost as your private cost. Okay, that's condition for idea. Okay? In other words, we want to replace the externality by taxation. Okay? So impose condition on, okay, that that is marginal cost, okay, becomes such that, okay, such that price cost, so this price cost with the toll, okay, with the toll, private cost, including toll, including the toll, is the private cost including the toll. It's exactly same as marginal cost, okay, social marginal cost for that is we don't have to worry about this first term because you already consider it as your private cost. We only worry about the second term that your new private cost including becomes that marginal cost. Then so how can you design this toll? If you charge congestion toll, so toll should be then become, so toll should be designed such that So this tau is a function of t. So tau is a function of t becomes okay. So in other words, the externality term is now replaced by congestion toll. Then now you will regard this congestion toll as your own private part of your own private cost. Okay. Then plug this congestion toll into that formula. Then your private cost then becomes marginal. Then what is the outcome then? Outcome is social law. The outcome is social law. Outcome is socially optimal. Okay. In other words, okay, equilibrium. Okay. This is equilibrium, meaning that consistent with Nash equilibrium. So individuals push their own interest, then the outcome will reach this equilibrium. Now, but no pooling policy. That is average cost, including the toll, okay? And the demand curve, and then this is a new private cost. This is new private cost. And this is equilibrium check volume on the toll, okay, on the toll. So if we impose congestion toll, that the congestion toll is exactly the same as the externality cost, is because by design, by construction, this new private cost is equal to marginal cost. Then this new equilibrium will be exactly the same as the total. Okay. Exactly the same. So, yeah, the idea is very simple. Okay? Because you don't care about externality, I made you to care about externality. So by requiring that you pay the externality cost. Okay. So in other words, I make you to internalize the externality cost. Externality is external, but I want you to internalize your cost. The idea is that, okay, so you pay the congestion. Right. So that's why I know that you don't like this idea of charging some additional fee for your delivery service, okay? Especially during midnight or midnight, because it makes noises for delivery services. The motorcycles make noises, and then it also contributes to congestion, okay? And also it contributes to more accidents, okay? The idea is that, okay, so the consumers don't care about the externality that generate by ordering these delivery services. So I want you to pay for the externality so that your external cost is internalized. Okay. So then the government may impose fees for delivery service. Yeah. Similar, same ideas as this one. Okay. Okay. Yeah. Okay. So repeating. Okay. So you can just read them. Okay. Okay. So you can read them. Okay. Okay. Then and then. So that what is then toll? So toll is basically toll. Toll. I said toll is So let's use notation tau. Now I said that it is a function of t. Okay, what do you mean by that? Why is it a function of t? It's a function of t in the sense that now there's a function for function. Okay? This is total function. Okay? And then this is what this is basically MC minus AC, which is t g prime t. So by definition, this is a function of t. Okay, so it is gap between the vertical gap. So vertical gap between the MC and AC curves. Okay, this we describe here. So the vertical gap. Okay, so okay. So again, okay. So I know that I'm repeating. Okay, so I add this congestion toll to your private cost, then this marginal cost becomes your private cost. The toll is exactly the external cost. Okay, so external cost here, then it is why it becomes widened as t is higher. Okay. So that's why it's called function. Okay. So the function in the sense that when t is small, the total amount is small. When t is big, the whole amount becomes bigger. However, what is the total exact total value? What is the congestion total charge? Total value, in other words. So it should be distinguished from should be distinguishing full value, full value, full amount, full dollar value of the how much will each person charge? So that is particular value, but that is a function. Value is calculated by evaluating the function at a particular point. Let me go with it. So, marginal cost, average cost, okay, and then we have the demand curve, okay, we have this demand curve, and what is the total value here? So this is old equilibrium, and this is new equilibrium, and that is socially optimal. It's the total value. So this point is socially optimal. This point is socially optimal, right? This point is new equilibrium. So if we impose congestion toll, okay, congestion toll, then there will be that number of waves under the new equilibrium. Then when there is that particular number, each person will be charged this amount. Okay, so that is total charge, total value, total dollar value per the freeway user. Okay, the freeway user. Okay?
how much will each freeway user pay in the form of toll that is that particular value. Because in equilibrium, in the new equilibrium, there will be that number. That is basically, because it's just toll schedule. Toll schedule is how it's a function of t. Now evaluate it at t. Okay. In other words, evaluate this function at this point. That is t multiplied by j prime. Just calculate the function at this point. That is the full number. Okay. Yeah. So then my question then is, what is the total revenue? Revenue. What do you mean by revenue? Revenue means it's a okay. Revenue. Revenue. The total dollar amount that is collected by the government. The government will collect, this total revenue by this rectangular. Each person will pay this amount, let's say this is $2. And then how many people will pay for that? There will be that number of people who will pay the toll charge. Okay? The multiplication of dollar per person and the number of people who pay condition toll charges is this full revenue. Full revenue. Okay? The government happy to get this revenue, and they will use for their own. Okay? We have to believe that they use it for welfare, the society's welfare, not for their own private, personal, benefit. Okay, revenue. So the underlying assumption is that the government officials are good. Okay, so they make good things for the society. So this total revenue to be recycled. So we call it recycling of total revenue for the improvement of the society's welfare. So that is the underlying condition. Okay, if we don't trust the government, then this model is not relevant. Yeah, but then let's ask this way then. Okay, so next question. Do you like the idea of congestion? You may use freeway, or you may use subway. You may use other things. You may use your own. You may even bike. You may walk. Okay. Do you like the idea of congestion toll charge? I mean the congestion tolling policy. If people like this policy, then there would be this policy in Seoul. In Seoul, we don't have such policy. In Korea, we don't have such policy. You may say that that's really small. It's not wide policy. We have a technology of developing this policy, meaning that we economists and engineers, traffic engineers, have developed the ways to quantify congestion schedule as a function of volume, and then if we apply this function, then we can compute the condition flow as a function of time and volume, and then we can implement condition flow. But still, condition tolls are rare in the real. Only some small cities such as Singapore and Stockholm, maybe London in part, and then maybe New York City in this adopting Poland. Meaning that most other cities they do not still have not adopted policy. The reason is because people don't like it. The reason why we don't like it, you don't like it because you pay more than people. instead you pay more than before. For example, who's specifically who pay more than before congestion toll? Your cost is only this amount. Yeah. So you only this amount. The freeway user, the cost of freeway user is only. Now after the imposition of congestion toll, so the private cost, including your time cost, plus is that amount is higher. Right? Okay? The freeway users are hurt by this policy because compared to fair tolling policy, your private cost is now higher than you have to pay, including the congestion toll, your cost is extra. So that's why many drivers in New York City strongly against this tolling policy in New York City. Okay? Because they have to use the freeway. Because they have to use these roads anyway. Some are very inelastic in their adjustment. So for example, truck drivers, those who live on their truck, they have to continue to use their truck. They have no ways to avoid this condition. Those who have some alternate route, these people, if condition tolls are imposed, they can use the ways, they can use some other ways. They can even stay at home if they feel it's too high. They can work from home. They can avoid condition toll. They're okay. But these truck drivers, maybe taxi drivers, Uber drivers, they have no ways to avoid toll. And in other words, there are people who don't care about condition toll. There are people who strongly hurt. In other words, there are people who are work on this policy and don't work. So that's why the equity concern censorship. It's important for the equity concern, and then there's political conflict. So who is more organized, okay? And who makes more organized voice? So but economics is about the aggregate welfare. The first goal of economics is efficiency. So efficiency, okay, this is certainly good. So, but there should be an underlying condition. The underlying condition is that it's total revenue, not wage. It's total revenue. So when we said that your cost is now higher than before. So before was this amount, after this amount, right? When we said that we overlook the fact that this revenue is way. This revenue can be redistributed. Even if you pay more, what if I return this revenue to you? What if I exactly return back this revenue to your pocket? Okay, then this revenue is not your cost. It's actually neutral. So once it is kept by the government, it can be used to return to the taxpayer. Okay? So this revenue is not waste; it's actually welfare neutral. We call it welfare neutral. It's not minus, it's not plus, it's zero. So revenue is just transfer from the taxpayers to the government. So given that this is not actually higher cost. Okay? So this is not actually higher cost. It can be potentially returned back to you. But still there are concerns here. So even if we believe that these are returns, they benefit from this revenue. Okay? I mean here, this revenue is shared between freeway users and non-freeway users. So only freeway users pay for the imbalance between the users of the revenue and payers of the revenue. Okay? So that's why I said truck drivers are strongly against this following policy, right? Because they pay, then what they pay is shared among, among whom? Among the entire population. Those who don't use the freeway, those who don't pay they enjoy from this revenue. So we need some political, steps to persuade these people. Even though we make sure that you benefit in terms of your lower income tax. Still, there are people who lose from this policy, and still people who gain from this policy. But summing up these welfare losses and welfare gain from this policy, what is the net welfare gain? The net welfare gain is net welfare gain. So we all discussed this all everything here. Okay, so net welfare gain is this blue area. Okay, this is a potential gain. This is potential difference in the grand total cost before and after the congestion tolling policy. So under the assumption that this revenue is well maintained by the government, then the exact amount is returned back correctly. The original amount is correctly returned back to the taxpayer. Okay, but then under that assumption, potentially the society can gain by this amount. Okay. Okay. That is the potential, the maximum that we can. The potential is, we call it potential gain, not realized gain. So it is right. So the potential welfare gain from congestion policy is the welfare loss of congestion. Exactly the same. Welfare loss of congestion can be recovered. Okay, when congestion toll policies are implemented. Yeah. So it depends on how the government do their job well. Do they, use direct revenue to improve the welfare of the society? I believe that they are doing well, okay? But I personally don't think that this revenue, the full revenue, is returned back correctly to the my discontent about how the government administration, the bureaucracy, what is that? There's huge administrative cost. Okay, huge administrative cost. So whenever we go through some steps, they require, for example, huge amount of people administrative bureaucratic cost from the bureaucracy. That's right. I mean, this revenue is expensive than what the taxpayers. So we have to pay, for example, yeah. Anyway, yeah. So anyway, so for textbook lesson, so this is potential gain from condition tolling. Okay. Any questions? So thus, what we can conclude that when toll revenues are appropriately redistributed, commuters can benefit from tolling. The welfare benefit from tolling can be quantified by the blue triangle area. This is equal to the deadweight losses of congestion under the losses fare. Okay. Real world toll. Okay, so it's very rare. Okay. So tolls are implemented in cities such as Singapore, London, Stockholm, and San Francisco. Recently, New York City, and the reason why it is rare is because people are against this policy, and people don't trust the government, and then there are equity concerns. Okay, so there are people who are hurt by this policy, and then there are people who gain from this policy, and then there's sometimes these people who hurt from this policy are more organized, and then they make more harmonized voices to the government so that this policy cannot be easily passed. Yep. So I have another slide, but I have, but I want to write down. Okay. Okay. So no way. Um. Or okay. We're doing Zoom recording. Okay. Okay. Yeah. But then we can write on the whiteboard. Okay. Okay. It's okay. Yeah. My next question. So we're going to use this model to explore many other things. Interesting. So one question that we have is, so we always discuss negative externality. Negative externality. My question to you is, can we model positive externalities in the same framework? Positive externality. Okay. Yeah. So positive externalities. How can we model? Okay. Positive externalities in the same framework. What do you mean by positive externality? So think about this road congestion. Is it possible for road users to generate positive externality? Under what situation they generate positive? You can think of a particular example is as follows. Okay, too few people is not good. So individuals may help other people, especially in emergency. I know it's a very hypothetical, but we can think of the situation. We can consider this particular situation as follows. So we always assume that this private cost is increasing. So my question now is it possible that private cost decreases? Okay. When would it be decreasing? In other words, under what situation the cost per freeway user is lower, there are more unity. In other words, here, when there is just one person, just myself, my cost is high. There are some people who travel beside me, the cost may be low. Psychological issue. There are some psychological issues. So think about the very dark night, midnight, nobody on the freeway, too dark. Okay. Then you got the emergency situation. Flat tire. Your tire is flat tire. Go on, and then you have no phone. You're driving by yourself. No ways to get help from others. That's good, right? So because you are worried about that emergent situation, sometimes you become more comfortable when there are some people who are driving within you. So it's not good if you just by driving yourself, but some level of traffic may be good for drivers. If they can help each other when there are emergencies. Okay? Right? So that's why it can be decreasing this way, but then it doesn't matter. But then once it becomes this high traffic volume, we up. Right? We only analyze this case where demand is so large. The demand function, the large demand, then in this equilibrium, we can say that there's too much traffic on the freeway, then another will help. So what if demand is so small? What if demand is so small? This is demand, small demand. This is nighttime demand. Okay? Midnight demand. This is daytime. Okay? And then this is equilibrium. This is equilibrium during nighttime. Okay? Then my question is then, okay, what is the socially optimal traffic volume during nighttime? How many people should use the freeway during nighttime? So to answer that question, we need what? This is average cost. Okay? We need marginal. Because marginal cost indicates social. Okay? So whenever so this is U-shaped, right? So this is U-shaped, okay? U-shaped for marginal cost. When so we learned that at the minimum of average. So this is U-shaped, nice U-shaped curve. The minimum marginal cost path to this minimum. Okay. So after that, after this point here, so in other words, when average cost goes up, when average cost is positively sloping, marginal cost is up above the average. Above average cost. Okay. The higher marginal cost, then average cost rise, average cost up. Okay. So we'll learn that. Okay. We'll learn that. Okay. So whenever average cost goes up, marginal cost is above that. Whenever average cost goes down, it's decreasing. Marginal cost is below the average cost. So this is the marginal cost. Okay. Now it's clear where the social optimum is. It's part of where it's the part where that we analyze. This is social optimal, which is less than the equilibrium percent. Okay. So now here, this is nighttime equilibrium volume. And this is lifetime net volume under social optimum, which is determined at the intersection of the nighttime demand and margin. The claim here is that okay, there should be more freeway users than under the equilibrium. So, it's not quite relevant for the real world, right? And so first we have to make sure that the outcome is between the hypothetical. We just want to analyze positive externality within the same framework. We can analyze in the by the negatively sloping average. When average cost is decreasing, okay, when average cost is decreasing, they'll exist positive externalities, and the optimal traffic volume is larger than equivalent. So what do you mean by positive externality? So here, before that, in this phase here, there are negative externalities in the sense that marginal cost is greater than the difference between marginal cost and average cost. That's negative externality. That's positive. That's negative externality. Here, whenever marginal cost is here, whenever marginal cost is less than that, okay, so less than that, there's a negative externality. Negative externality is negative, right? So then there's a positive externality. Okay? Negative externality is negative, positive externality. When marginal cost is below average cost. Okay. Yeah. So classroom example. So your example. Okay. So we have, we have 90 students in our classroom. Okay. Do you generate positive externalities or do you generate negative externalities? Okay. Okay. Before, no students went for military. People generated positive, negative externalities. Why? Because the classroom was too small for 90. Okay. But now, given that many people went for military services, the classroom is too small relative to the optimal size in the sense that because you interact, okay, so you interact with other people. You want to study with your friends. Okay, then maybe 5 students in the classroom is too small. 90 maybe too big. 5 students maybe too small. Because you can share your knowledge. Because you can share your homework. You can solve your homework questions to knowledge exchange. Okay. So when yeah, so that makes sense. Okay. Now we can analyze positive and negative externalities in different ways now. So we considered the case where average cost depends on T. Okay? Negative cost depends on cost depends on cost for user depends on cost, okay, for user, okay, depends on T. So depends on T. T is what? T is the number of users. It's a cost. So G is a function of T. Okay, so that's average cost. Average cost is a function of T. So that's what we analyzed.
which let's change cost to benefit. Let's flip the expression. Now, what if benefit? Okay, benefit per user depends on T. So let's use average benefit notation. Average benefit. Does it make sense? Total benefit is benefit of all the users. And what if it depends on T? And how come it makes sense? The typical example is amusement park. So it's called particular example is Everland. Okay, Everland. What is it called? Amusement park or what is the term that indicates that refers to Everland? So let's say it's amusement, Everland or Lotte World. Okay, so Lotte World. You enjoy benefit from visiting these parks, okay? Or Caribbean Bay, okay? So those are the parks that you enjoy. Your benefit depends on how many people are there, okay? So in particular, maybe this is dollar value. This is dollar value. Okay, dollar value. Maybe there's a target economics when there are too few people Disneyland. So when just you, if you may say that, okay, I enjoy all parts by myself and my family, my friends, good. For most of you, you're social, you're social persons, you're social, you want some social interactions. When it's just you, it's at the park, it's not very fun. It's not very fun when just when there are only couple of people with you. So that the enjoyment, okay, from visiting the park goes up if there are more people. Does it make sense? Okay. Sometimes I feel that people want to go to more crowded, streets because they want to hang out with these people. So that 0% and 2 people not good. Your enjoyment, your benefit from visiting the park goes up if there are more people. Okay, more people. But then after this point here, it becomes now congested, it's crowded. Okay, and then you don't like it, okay, because so many people you don't like it because you have to wait long time on the facility, and then your benefit goes down. It's a inverse U shape. Initially, as there are more people, your benefit per person, benefit per part, visitor goes up, goes up. But then after that, at a certain point, it's congested and crowded, and it goes down. In other words, your benefit depends on how many people there are with you. Then there are both positive or negative outcomes. Okay, so we are sharing this facility, the classroom, with the 70, 80, and 30. So few people, many people. That's why I think Sorbonne University is one side. That they were university that too big, Sorbonne University, maybe. But then, this is the average benefit. Average benefit, okay. Then what is the marginal benefit? Marginal benefit is include average benefit plus the externality. Knowledge. The benefit that you generate. The marginal benefit, so whenever it is going up, the society's benefit is higher.
marginal benefit. Marginal benefit. So whenever marginal benefit is higher, then this higher marginal benefit drives the average cost, average benefit up, and after that it goes down. Okay. Okay, so see you on Thursday.
모든 날 대비군 모르게 되면
네, 똑같이 하려고 해요.
똑같이 하는 거죠.
아니요, 그 머리값, 그 높이만. 빨간색.
얘만이면
요 폭탄감.
호감각 전체를
그쵸. 오케이. 잘 된 것 같아요. 꺼야 될 것 같아요. 몇 번인지 모르겠는데. 경제가 언론해야 되는 거잖아요.
네, 맞습니다.